Fine. Good morning, good afternoon, good evening, everyone, and welcome to the Data Analytic Group this year, 2026, the first session with the Frank. And to everyone, Happy New Year. And let me give a glimpse of Frank Glacier. So Frank and myself met at Microsoft AI tour, and he's very good. I mean, now after that time, I was got very good contact, and as well as he's very helped me in the giving a sales presentation as well. So I'll just try to introduce the Frank. He is the CEO for the GDS Business Intelligence, and he's also fellow MVP on real-time intelligence part. And he's going to give a session on releasing the potential of Microsoft real-time intelligence via through AI agent. So I'm interested to look over how this AI agent as well as the real-time intelligence has been configured and automated process. So Frank, you there, right? I'm handing over
Yes.
the stage to you. So please proceed and excited for your session. Thank you.
Okay. Thank you very much, and a happy New Year from me as well. So I will start by just yeah, as you already said, let's see. We're talking about releasing the potential of Fabric real-time intelligence through AI agents, and this is something I would like to show you a little bit on, and probably we have a very small demo in the end. But the thing is, what I want to do is I want to tell you a little bit about the different technologies that can be used here, and also a little bit about why do we need artificial intelligence for certain things. So first of all, a little bit a slide of me. So I'm the CEO of GDS Business Intelligence GmbH here in Germany. I'm Data Platform MVP, or meanwhile, I'm Fabric and Real-Time Intelligence MVP. Have a lot of certifications, and I do a lot of stuff in the community. Anyhow, this is not about me. Maybe only one or two more things. One thing is, at the moment, I'm writing with my very good friend Johan Brattas. I'm writing the book Real-Time Intelligence with Microsoft Fabric. We are nearly done, and this book will be released somehow in spring of 2026. And another thing I would like to tell you as well is the next slide. So at the moment, Kevin Chant and me, we are doing a podcast which is called the F Files, for the Fabric Files. And maybe, I don't know how old you are all, but maybe one or two of you might remember the X Files from the TV series from the 90s, right? And this is also something we do here. So what we do is there is the Microsoft certification pages, and on the Microsoft certification pages there are these assessment tests, right? And what we do in each of our episodes is we grab one of the questions, and we will discuss which answer is the right one. And at the moment we have like 7 episodes, much more to come. And if you're interested in this, there is at the moment we are only on YouTube, but it is planned that we will be on Apple Podcasts, Spotify, and so on as well. If you're interested, please feel free to just subscribe to our channel. And well, this is it. So let's go and start with the session. So first of all, what I would like to do is I would like to tell a little bit about different technologies. I would like to tell a little bit about real-time intelligence. What you will walk away with is an understanding of agents, understanding of MCP servers, understanding of data agents, how this works. Very important is understanding the sample that I and one Microsoft guy here from Germany came up with, and understand also the sample architecture. Whenever there are any questions, please feel free to just put them in the chat. And if there are questions, Rajendra, please you can always interrupt me, and then we can talk about the question. Right? Okay.
Definitely.
So let's get started. So first of all, I would like to describe what the problem is we want to solve, right? Because these days, everyone is talking about AI, right? AI here, AI there, AI there. And what is very, very important is to think about, first of all, what is the actual problem we want to solve, right? And afterwards, then when we understand the problem, then we can think about, okay, could AI be a possible solution for this problem, right? Because I don't know how you feel about this, but usually when I talk to people, it is like, hey Frank, let's do something with AI. Where I say, yeah, okay, but what is the problem? Why should we use AI? What do we want to solve here, right? And the other thing is, what I also see a lot is that people talking about AI, and then you see, well, probably for this problem you have at hand, you don't need AI. What you need is like an Outlook rule or something, right? And this is and so I would like to introduce the problem, and then and I will also tell you why for this problem AI would be a good solution. Okay, next thing is I will talk a little bit about layering the ground, about all of these different technologies that we put in there. And my friend Marcel and I, when we did the session the very first time last year in Gothenburg, we were a little bit overwhelmed of all the technology we wanted to introduce, and we're thinking about that we might do the session sometime as well as a pre-con to a conference or something like this, because the different technologies we use are huge, right? And we are talking so much about these different things, so it's 1 hour is rather a little bit short, right? And in this case, what I will do is I will give you a conceptual overview over the different technologies. Then I will show you a little bit of the architecture of our solution. We can talk a little bit about on this as well. And I will show only a little demo that you at least have seen, okay, this is how it looks like if we have this in the Fabric portal, and this is how we can solve this. Okay, so let's start. Let's start. What is the problem that we would like to solve? Okay, so imagine following. Imagine it's a sunny day in London, right? Your favorite metal band Metallica is playing in Wembley Stadium. In this case, 60,000 fans are joining, right? Many people. There is one big problem with this. After the concert, there is, as always, a traffic jam. And this can be very, very severe. I can tell you one story I was experiencing myself. I was attending a conference at Hockenheimring, and after not a conference, a concert for sure. And after the concert was done, it was like midnight or something like this. We wanted to get off the concert ground because we want to go to our hotel, right? And the problem was that there are so many people, and they didn't do a good job of getting away these people from the concert ground, that there was no way that we could use public transportation. So what we did is we used public transportation to get there, because I wanted to drink a beer as well, and I don't want to drive a car. And so we were relying on public transportation to get away. We didn't manage this until 2 a.m. in the morning, and then we just thought, okay, now we really want to go to our hotel. So we just stopped some random car and asked the guy if he wants to earn some money, right? And he said yes. And I said, okay, perfect, then you will get money, and please drive us to our hotel, right? And this is how I invented Uber. No, just kidding. But yeah, this is a problem. Okay, so there must be some other solution, right, to get home again. So I was thinking, well, I will use a bike, right? Thing is, it will not be such a bike, because the problem is I don't have a driver license for this, right? It will be more like this bike, right? Okay. So luckily, as you might know, in London, there are many of these bike points, and there I just can rent a bike, right? And this is the theory. But the problem is, sadly, these bike points are empty, so I don't have a bike. Right? And the real problem is even bigger than this. So if we're thinking about the real problem, then the real problem is, okay, there are some really, really big venues in London, right? Then there are some medium-sized venues in London, and then there are some small venues in London, and you have all of these bike points, right? Where you can just rent a bike and then return it again, right? The other thing is, it's not only about this, it's also about this here, about the weather, right? So London is a big city, And as you might imagine, in this big city, there is also different weather. So there is in one of the boroughs might be sunny, in one of the other boroughs might already rain, right? And so it is also this is also some influential thing within all of these different this different or with all of this scenario that the weather plays a role as well, because people are more tending to use a bike if it is sunny than if it is rainy, right? Okay, so I was thinking about, well, there must be some kind of a technical solution to this. And I was thinking a while, and I was thinking, and even more thinking, and then I came up with, together with Marcel, with a friend of mine from Microsoft, we came up with some thoughts about the whole situation. So first of all, we were thinking about, okay, why, if we look at all of this, why is linear programming not a solution for this? So first of all, if we think about these rental bike things and the events going on in London and the weather and everything like this, so the problem space we have is it is not static, right? So there is not a single objective function you would like to optimize for, right? Because this is too complex. Another thing is, you might know that it is regarding or in comparison to static data, it is a little bit harder to model event-driven data, because you have these event streams, you have the data coming in and stuff like this, and so it might be a little bit harder to do this modeling than if you're just thinking about static data within a relational database, right? The other thing is, and this is because this is real time and people rent bikes, people return bikes, weather is changing, stuff like this. Because this is real time, the constraints of what you want to optimize for are changing all the time, right? And the other thing is the data is heterogeneous and, well, unstructured or at least semi-structured. So the data we will get in is more like JSON documents, right? Because we get these JSON documents from the bike stations. We get some JSON documents from the weather service. I will show you a little bit later. So it's not like a clean relational database, right? So and set this whole very dynamic situation, right? You need continuous re-optimization and not periodical recalculation, because it has to be optimized as things are going, as things are starting, right? So if we're thinking about how we should distribute these bikes, so human reasoning is required, or human-like reasoning, because we have to take into account the venues, how large the venues are. We have to take into account the weather. We have to take into account where the bikes are, all of this, right? And this is something we have to take into account, right? And when we master all of this, right, we can also think about new kind of businesses here, right? So thinking about these bikes, you have all of these bikes scattered around London, right? And probably the bikes are not there where they should be, right? And what you don't want to do is you don't want to have a truck and you just put the bikes on the truck and then drive the bikes where these bikes should be used. But what you could do is, and this would be, for example, another interesting kind of business solution here, what you could do is you could maybe offer people on the bikes, you might offer them some discount or something like this if you say, okay, please return the bike at this bike station and not at this bike station. Because what you do as well, because of all this telemetry data, you also know where the bikes are, right? And if you say, okay, yeah, I see that you're heading here, but maybe if you don't go to bike station 23, but only to bike station 24, then and return your bike there, then this bike might be in some area where the demand of bikes is much bigger than with the other bike station. And you can incentivize this in just telling the people, okay, look, you will get a discount on your rental or something like this if you just return the bike to another bike station. And this thing doing in real time, right, on the smartphones of the people renting the bikes. So the other thing, which is also interesting here is, or which is also not interesting, but kind of a concern, is that you have these feedback loops, and these feedback loops break linear assumptions because the problem space is not linear, right? And what you could do is you could say, oh, well, we can just solve this like we did in the past, and we can just use, for example, combinatorics, right? Like a chess computer or something like this. Because the chess computer, as you know, the chess computer is not reasoning at all. The chess computer is just doing combinatorics of all of the possible plays, and then just selecting the one with the highest probability that it will win. This is what the chess computer is doing. The problem is, if you are thinking about combinatorics, this in this case, this just will not scale because the problem space is too big for this, right? And you cannot just calculate all of the different things you're seeing or you're thinking about. You cannot just calculate them in advance, right? And the other thing is, so thinking of classical models, probably this autonomous action is not a part of a classical model. Okay, so I just gave you this example because we think that this example is a good example for why we need AI. Because this is something which might be a little bit difficult to solve if you don't have AI. Do you have any questions on this? Any questions, anyone? Okay. So now we understand the problem. Now let's have a look at the technology. So what I will do now is I will lay the ground for what is the point with all of this technology we might use here. And we will start also what I will cover. And as said, there is much technology we just put into each other and we combined with each other to build this demo use case, right? So what we will cover is we will cover fabric and real-time intelligence. Maybe could you please show hands? Who of you already heard about fabric? Some hands? I see 1, 2, okay, 3. Okay, perfect. Yeah, it doesn't matter. Okay, now there are coming some more hands up. So we have, I think, six or seven people, and we are. Let me see. We are some more. So, well, doesn't matter that people don't know about Fabric because I will tell you a little bit about this. Next thing is I will talk about agents, and I will also talk about the differences between agents and chatbots, right? And what is the essence of an agent? Then I will talk a little bit about MCP, the Model Context Protocol, right? And I will talk also a little bit about the RTI MCP server. So I didn't update my slides. There recently, the Microsoft also published an MCT server for Fabric, and not only for real-time intelligence. Then I will talk a little bit about Fabric data agents, and at the end, I will talk about AI Foundry, and then we will have a look at the at our architecture. Okay, so let's talk a little bit about Fabric. So what is this Fabric thing? So when you are working on analytical solutions, right? It is always very cumbersome to put together an environment for analytical solutions. You have to take care of the part of data ingestion. You have to take care of the part of data storage. You have to take care of the part of the analytics itself, right? And some, or in many times, if you just do this by combining some different technologies, right? You even probably have to copy over the data because technology A cannot work with data which is stored here, and technology B does need data somewhere else. So it's a very cumbersome process to build a good analytical solution, right? And so usually, if you're thinking in enterprise scale, usually this will be a project that will last for 3 to 6 months to just build the platform, right? And while this 3 to 6 months, no one has analyzed anything, right? Because it's only about integration. It's only about will this product work with this product and stuff like this. And this is not all. So the other thing is, you will pay different vendors. Different vendors might have different payment models. So maybe here you will pay per user, and the other thing is you will pay for like pay on pay as you go or something like this. So it's also very difficult to just get an understanding of how much do I have to pay. The other thing is, with all of these different technologies, to do a really good job, you have to have for each of these technologies a specialist who knows about this different kind of tool, right? And what makes it even worse is each of these different technologies has its own security. So if you want to do something security wise, you have to have security here, you have to have security there, you have to have security there. Some scenario for this could be, for example, you are ingesting data through Informatica, you have the data in SQL Server, use then Databricks to analyze the data and maybe do some machine learning models, stuff like this. And then in the end, you use Power BI or Excel or whatnot to visualize the data and work with the data, right? And through all the steps, and this is to be honest, this is a very easy setup, right? Usually these setups are much more complicated and it's very cumbersome to build something like this. And Microsoft thought, well, let's do it the other way. So what we can offer is we can offer an analytical platform as a service, as software as a service. Maybe who don't know what software as a service is. Think about your private email address. So when you created your private email address, you went to one of the big vendors, like for example, Google or Microsoft or wherever, logged into Outlook.com. Then you are asked, okay, what should your email address be? Stuff like this. And then you just accept the terms, and then you have an email address. In this case, what you don't have to do is you don't have to set up your own email server. You don't have to deal with how can this email server talk to the rest of the internet. You don't have to deal with, okay, how do I have to do backups of my email server. You don't have to deal with what is happening if my email server is not working anymore. These are all topics that you don't have to deal with because this is what the software as a service platform just is doing for you, right? The only thing what you do is, well, I put in my name, I put in my email address, and now I can start sending email to people without understanding the foundation for this, the technical foundation. And this is exactly the same that Microsoft was thinking for Fabric. So it's very easy to start Fabric. You could either use the trial accounts or the trial capacity to create trial capacity to use, or the other thing is you will just initiate a Fabric capacity within Azure, and then you can use it. So thinking about Microsoft Fabric, it has different pillars which will do different kind of or different jobs within our analytical platform. So first of all, there is one pillar which is the data factory. This data factory is everything you need to ingest data into Fabric, right? So data factory has different items that you could use. One of these items is Data Flows Gen 2. Data Flows Gen 2 is very Data Flows Gen 2 is something which is very common to you if you're using Power BI because it is more or less Power Query within a browser, right? There is one very important distinction between Power BI, Power Query, and Data Flows Gen 2. And this important distinction is that in Data Flows Gen 2, you can specify or you have to specify a data sync where you write your data. This is something you wouldn't do in Power BI because in Power BI, usually the semantic model, which is behind your Power BI report, is the place where the data will be written to if you import data, right? And other things are like data pipelines. With this data pipelines, you can orchestrate your different data loads and use this to put data into your Fabric estates. So then you have analytics. Within analytics, what you could do is you can just create notebooks, Python notebooks, PySpark notebooks, which will be executed on a Spark cluster. And within these notebooks, you can have all of your analytics to just analyze your data. You can have your machine learning models in there and do all this AI stuff. Another thing what you could do as well is you could use SQL to analyze the data as well, right? Then there is an interesting thing which is called databases in Fabric. Databases in Fabric at the moment supports Azure SQL Database and Cosmos DB. And what this will do is this will just give you the option of having a relational database within your Fabric environment. So in this case, what you don't have to do here is you don't have to set up your database in the complicated way you will do with Azure, because if you're creating stuff in Azure, you will be there will be plenty of forms you have to fill in with technical information to just build, for example, an Azure SQL database. And in this case, this is not the case. It's much easier. And the other thing is that that all of the resources you will use with this database will be on your Fabric capacity. So this will be charged against your Fabric capacity as well. And the big advantage is so you will just create a Azure SQL database like database. And now you might ask, okay, Frank, why should I do this within Fabric? Because I can just create a Azure SQL database in Azure as well. So why do I do this? So the thing is that and I will just tell you a little bit about this, and then I will get back to this. So the thing is that all of the data which is stored in Fabric will be stored in the OneLake. The OneLake has two main functions. One of the functions is this is the data layer, and as a data layer, the OneLake is an Azure Data Lake Gen 2. Right, but not like the Azure Data Lake Gen 2 from Azure. This is a Data Lake Gen 2 which is in kind of a managed environment, right? So this is one thing, or one of the purposes of OneLake. The other one is of data virtualization. So the idea is to have the OneLake as the central data storage solution for your environment. And it is like the OneLake is also you can also access data from the OneLake which is outside of Fabric, and this data could be, for example, at AWS, could be at Google. What you do here is you create shortcuts, and these shortcuts are like pointers which don't copy over the data. They point to, well, over there is some more data, and you can just access this data through the data lake as if the data would be in the data lake. Might be a little bit slower, but this would be a good idea, for example, to create your Bronx layer within your architecture, to just not, so you don't have to copy over terabytes of data from some other cloud provider or something like this. So, and what these databases do is these databases will automatically mirror all of the data which is in the database into your OneLake, and this can be used. This can be used in your analytical solution as well. So if you're using databases within Microsoft Fabric, you don't have to implement some data ingestion to the OneLake, because this is already happening automatically. And in this case, and the other thing is with the database in Microsoft Fabric, you will have a connection string like to any other Azure SQL database, and you could use this connection string. You could just use it in all of your applications who need a SQL Server as a database backend, right? So next thing is real-time intelligence. I will not tell you too much about real-time intelligence on exactly this slide, because the next slide will explain it a little bit more, and I will just show you a little bit more what real-time intelligence is about. Maybe one thing I would like to at least to foreshadow a little bit is real-time intelligence is about streaming data. So thinking about Fabric as a data platform. This is on the one hand, if you're thinking about ingesting data, right? Then you have two kinds of data you ingest. One kind is batch loading. This batch loading is exactly the same process we do, I think 20, 30 years now, like just having a source system and a given time point, at a given point in time, like for example, 2 a.m. in the night or something like this. Our analytical solution will just load the data from the source system, right? And we'll just put it in. This is how data warehouses work, right? The other thing is streaming data. So data will be streamed into our solution at that time the data is created. And this is where real-time intelligence comes into play. This is what real-time intelligence is scoping in the whole Fabric environment, right? I don't think I have to introduce Power BI too much. Maybe any one of you don't know what Power BI is, right? I will be happy to explain, but anyone who don't know, I think everyone knows, right? I will wait maybe some seconds to zip a little bit of coffee, and so okay, everyone, thumbs up, awesome. So Power BI is just the virtualization tool we all love and we all know, right? Okay. So and Power BI is also the virtualization, the visualization, not virtualization, the visualization tool for Microsoft Fabric. And what Microsoft did is Microsoft changed from Power BI to Fabric. So Power BI is not like a product on itself anymore. So Power BI is more like a component of Fabric. And what they did, and I think they did a tremendous job there, is they implemented the whole rest of Fabric exactly the same the Power BI service was. So when we get into the environment, you will see that the things you know from Power BI, like workspaces and stuff like this, is still the same, right? But now you have a really big number of things you can create within this workspace. Not only Power BI reports, semantic models, stuff like this, right? And then let's talk a little bit about the foundation of Fabric. And maybe talking about the foundation of Fabric, there are three things on the slide. One we already covered, which is one lake, and there are two other things, and one thing which is not on the slide. So first of all, I will start with AI. So Microsoft is thinking about Fabric and about the one lake as the data layer for AI, which makes perfect sense, because if you're thinking about company data, right? Company data used for business intelligence and stuff like this. This is a very good source of data for AI as well, because everything which is to know about your company is in this data, right? And so this would be a really good foundation for your AI as well. And what you don't want to do is if you use AI, if you use, for example, a chatbot or something like this, you don't want that the chatbot, if you ask the chatbot, how was my revenue last year or something like this, you don't want that this chatbot just makes up some numbers, right? Which because it just, this is how chatbots work, right? So what you want to do is you want that the chatbot or the answers of this chatbot and also the answers for the agents will be grounded on the data which is in your company and which is in the one day, right? This is the one thing that Fabric supports. So thinking about AIs, we have two kind of AIs here. So one is, I always call it like a helper AI. This helper AI is Copilot, and this AI will support you by building stuff in Fabric. Like, for example, building data pipelines, writing T-SQL commands, writing KQL commands, all of this, writing Python code, all of this heavy lifting stuff. There are many copilots in all of the different experiences in Fabric, and you can use this different copilots to get your job done, right? The other thing is more that, as already said, that Fabric also can be used as a foundation for AI, as a data grounding to get your AI systems going. And these AI systems are more likely the AI systems that will be then used by some people in your company, right? By end users, right? Another thing which is also interesting and important with Microsoft Fabric is Purview. If we're thinking about Purview, Purview is a governance solution. So thinking about company data, there is, if we have a look at company data, there is much confidential data within your company data. There is, for example, person identifiable information in there, like email addresses, like phone numbers, stuff like this. There might be some other very confidential data in there, like, for example, credit card numbers or stuff like this, right? And what you don't want to do is you don't want that people can easily just copy over all of the credit card numbers in their Excel file and then send the Excel file to someone, right? So in this case, what you could do is you could use Purview, and with Purview, you can have sensitivity labels on your different data estates. And these sensitivity labels will take place whatever you do with the data. So think about this. Think about that you have a sensitivity label for confidential data. And within your Fabric data estate, there might be, for example, a table, or there might be a column or something like this. You marked as, well, this is confidential data. So this sensitivity label will be inherited wherever you use this data. So think about think about a controller. What do controllers do all day? Well, they use Excel, and then they grab some data, put it in Excel, and do some analytics, for example. So in this case, if the controller is using the confidential data, then the Excel file he's storing in SharePoint, or he's storing in Teams or somewhere, this Excel file will also get this confidential sensitivity label. And whatever you were defining within your tenant as rules for this sensitivity label, right, will take place as well. So if there is a rule in Purview which says we cannot send out confidential data to the internet or something like this, to someone whose email address is not in this organization, this will be true for this Excel file as well. And the cool thing about this is the controller, who might not be aware of the situation, does not have to mark this Excel file himself as confidential, because it will just inherit this sensitivity label from the data he was using in this Excel file. One last thing to this slide, what is missing here is, I think it's an important thing, is Entra ID, because Fabric is relying on Entra ID as well. And the thing is that Entra ID, but all the options and all of the functionality Entra ID has, can be used with Fabric as well. So what you could do is, for example, you could use conditional access within your environment to have conditional access on certain kind of data. So if a person, for example, is outside your company working with a non-company device, this person is not able to access this data. She's only able to access the data when she's inside the company and working on a company-owned device, for example, right? And this is something you could do with Entra ID as well. Another thing which is also interesting is you can use the Entra ID security groups within Fabric. Think about a security group for some kind of department, for the marketing department, for example. So what you could do here is, and you have already the security group in place because you use this security group for giving them access to SharePoint. You use this security group for giving them access to Teams. Maybe you even use this security group for software distribution through Microsoft Intune, right? And you can use exactly the same security group you can use within Fabric as well to give people of the marketing department access to certain kind of data, right? And this is pretty cool, I think. So now let's move on and let's have a look at real-time intelligence, which is this slide. So real-time intelligence, I will just grab my laser pointer so you can see this. So real-time intelligence consists of different components. So one of these components is the event stream, which you can see here. So the event stream is the representation of your streaming data within Fabric. Event streams are like a low-code, no-code solution where you can just configure how your data will be transformed and where your data will be stored, right? So what you could do, for example, is you have this event stream, and then within the event stream, you can have a filter which only filters certain kind of data because you don't want to have all of the data which is streamed in, and then write this data into a KQL database. And the KQL database is part of the event house, which is here. An event house is like a container for KQL databases. Maybe who has never heard about KQL? KQL is kind of a time series database that Microsoft developed when they were starting with Microsoft Azure. They were thinking about, okay, let's have a look at this gigantic data centers. Let's have a look at these thousands of services which will be in there. And so everything which we will do in Microsoft Azure will just create some logs. And we need a technology to to work with these logs and to analyze the logs to see if something's happening or something like this. And they were looking at the market and they didn't see anything which was suitable. So they developed themselves the KQL databases. And these KQL databases are very, very capable. So there are different experiences in Microsoft Azure where you could use KQL databases. So the very first one, which was published. The first was Log Analytics. Maybe some of you who dealt with Azure already know Log Analytics. Other things are Application Insights. This is also based on KQL databases. Or things like Azure Data Explorer is also based on KQL databases. And these KQL databases, as time series databases, are in Fabric as well. Just to give you an impression about how capable this is so the data ingest, if you're thinking about the data ingest that from Microsoft and from all of the Microsoft clients, which are ingesting data into the KQL databases, this is per day 350 petabytes of data. This is an insane number, right? 350 petabytes of data streaming into the platform each day, right? So you only have to wait for 3 days and you have exabytes of data, right? So totally insane. So what you can do with this data is you can visualize the data on a real-time dashboard. A real-time dashboard, so the technology, the underlying technology has nothing to do with Power BI. The underlying technology is is a separate technology and is aimed at this streaming, at visualizing streaming data. So it might not be as posh as Power BI, but it is more aimed at technical people wanting to see some things that change, right? The other thing, what you could use in real-time intelligence as well, are KQL query sets. This is more or less like how to say, not like a folder, but this is like a collection of different KQL queries which can be used within the Fabric environment from different people, right? So if you're writing your KQL queries, you can just put them into a KQL query set, and other people, like for example Rajendra, can just access queries that I put on the query set within Microsoft Fabric. Thing is, if you're thinking about all of this, it's very nice if you can visualize the streaming data that streams into your database. But the thing is, well, what's the point of this? Okay, it's nice, you can see this and everything like, but do you want to have some people sitting in front of a dashboard 24/7, and if there's something weird going on, taking the phone, phoning someone and say, well, there's something weird is going on? No, you don't want to do this. And if you're thinking about event-driven data, then it's also the case that if some severe things happen, they usually do not happen during office hours, right? So if there is a device is failing or something like this will be at 2 a.m. in the morning, right? And the thing is, what you could do with Fabric as well is there is a thing which is called the activator. And what the activator will do is the activator can spot patterns in your streaming data and can act on this. So for example, if we're thinking about package deliveries or something like this, and there will be plants in these packages, right? If the temperature drops below a certain temperature, then this is not healthy for the plant, and you might get a warning or might get an alert about this where it says, well, you have to deal with this package because it is too cold for too long, so maybe the plant will die or something like this, right? And this is what the activator is about. So activator can do some things. So first thing it can do is it can send you emails or it can send you Teams notifications. But and this is where the real power comes with activator. What it can also do is it can trigger Power Automate flows. So you can have this Power Automate flow, and the Power Automate flow will react on the data that is sent from the data activator, because what it will do as well is it will send all of the data that is in the data set that triggered this this action will send to Power Automate as well. And then you can build within Power Automate, you can build your logic to work with the data which is in the which is in your database or which is in your event. Don't have a database. Okay, any questions on real-time intelligence? Okay. And
Also,
if there, yeah. No questions? Okay.
No, sir, no questions.
Okay, perfect. So let's move on and let's talk about an AI agent. So what is an AI agent? So an AI agent is something like a digital decision maker that will observe data, think about this data, and then act on this data, and it will act on this autonomously, right? Um, so usually AI agents work with goals, not with rules, because what the AI agent shall do is the AI agent shall reason about the data it has and shall find its own way. And what they do is they can react in real time to changing situations. They can also use tools and trigger actions, and they continuously adapt and improve based on the feedback and on the outcomes. And this is exactly what we are looking for into our Metallica example, right? Because this is where we think, okay, we need something that is able to reason and to do decisions autonomously. So I have another slide here where I show you the differences between agent and chatbots. And what I won't do is I won't read the slide for you because every one of you can read as well. And I think there is no big point in me reading the slide. So I will quickly go to another slide to show you the differentiation between chatbots and AI agents. Think about you want to book a flight, right? So, and on the left side, you will do this with a chatbot, and on the right side, you will do it with an AI agent. If you want to book a flight with a chatbot, like for example, Copilot or ChatGPT, how will this look like? So you will say, I want to book a flight, and ChatGPT will answer or will ask you, okay, from where would you like to depart? Where would you like to arrive? And maybe which airline would you like to use? And if you give it all of this information, it will just go and then in this case, it will just give you like a plan or like instructions how to do this. Like, okay, first of all, go to the website of this airline and then put in your information on your departure. Put in information on arrival, put in there, put in the date and stuff like this. You know this. Yeah, I think every one of you has already booked a flight in the internet, right? But this is what the chat agent will do. A chat agent will give you only instructions, whereas the AI agent, will book the flight in your behalf, right? It knows about the different portals of different airlines, and it will book this flight for you. And this is another interesting thing to our discussion. If we're thinking about this, do we really want to have an AI agent working with data maybe from 2 weeks ago? Do you want to have your book? Do you want to have your flight booked with information from 2 weeks ago? No, you don't. Um, question is the AI agent integrated with Fabric? It is a new feature or service in Fabric. Yes and no. So very good question. Thank you for this, and we will come to this. Please wait for a few more minutes, and I think then you will get the point here, right? How this will work. Okay. So and I think everyone gets first of all what an AI agent is and why it is very crucial that the AI agent will work with the most current data it can get, right? And this is something I wrote. There are some articles on LinkedIn on this as well. Is this something what I'm seeing is that if we're talking about AI agents, we also talk about real-time data because this is the foundation for the decision making of the AI agent, right? Okay, so I have one or some more slides before I come to this topic of Fabric and AI agents, but bear with me. So another technology we use here is MCP, Model Context Protocol, right? So thinking about Model Context Protocol. So what is Model Context Protocol? Well, you can think about Model Context Protocol just like in USB, like USB-C, right? You can just use USB-C to plug in different devices, and it's like a standard. And the same is true for MCP. So looking at this is MCP is the gateway of an agent to some other tools. And it is because of this MCP protocol, it is like a standardized gateway. These other tools could be some things like, for example, you can see here, it could be real tools, like, for example, a calculator. You know that the large language models are not very good at calculating stuff because this is something they just were not constructed to do. So what a large language model, in a very, very easy discussion, what the large language model is doing is it is just cutting down all of your questions you're putting in there into tokens, and then through this vector databases it will use, and these vector databases are gigantic. Through this gigantic vector database, it will construct the answer just by probability of the tokens, right? I know this is very, very simplified, but this is more or less what it will do. And if you look at this, there is nothing in there which will calculate 3 plus 5 or something like this, because this is just not what LLMs do. So, but what can be done through the model context protocol is you can connect different tools, like, for example, a calculator, you can connect to an agent. And whenever the agent is asked to do some calculation, it will just hand off the calculation to this calculator in this case. And the same is true for other tools, like, for example, web search or for accessing data. So this is another kind of tool, will be data. Right? If you want to have data, or if you want to have access to a database, this will also be controlled through an MCP server. So there is one more slide where we can see this. So on this slide, we see there are different MCP servers for different services. In this case, is like the Google Calendar, it's Google Mail, it's Slack here, right? These are the remote services, and the MCP server can be seen like an USB hub, right? You plug in all of these different services into this MCP server, and so the MCP server could also be used, for example, to accessing local data. And then we have some kind of agent, for example, Claude, or we have Cursor, or we have ChatGPT. And these are MCP hosts where there is an MCP client, for example, client Python module. And these MCP hosts use these MCP clients to access the MCP server and to route certain requests, for example, for mail or for Slack in this case, route to the special service here. So looking at, where is my mouse? Let me see. So looking at Microsoft Fabric, there is a Fabric RTI MCP server as well. You can find it here. So you will have the recording of the session anyway. So you will find it here at this GitHub place. Meanwhile, so there is one drawback at the moment of the Fabric RTI MCP server, is that it only works with real-time intelligence or with the KQL databases. So you could use the MCP server as an MCP server on the one hand on a KQL database within Event House, but you can also use the Fabric RTI MCP server on an ADX cluster, for example, as well. So, but what you cannot do with this is you cannot use the RTI MCP server with all of your Fabric estate. And this is, and thank you for the question again, Almeida, this is where we get to the Fabric Data Agent. So the Fabric Data Agent is a new functionality within Microsoft Fabric, and this is like an AI-powered data assistant. So what you could do is you can use the Fabric Data Agent for neutral language processing to data interaction. So what you could do here is you can just ask it, okay, how many venues are in London, or how many bikes are in this bike station, stuff like this, right? And it will just answer this through the data. Cool thing is, if you create a data agent in Microsoft Fabric, you can explicitly tell this data agent on which data it should act on. Because what you thinking about, you build your medallion architecture within your, for example, within the Fabric Lakehouse or something like this, right? What you don't want to do is you don't want the Fabric data agent accessing the Bronx tables, because in the Bronx tables there is only data which is not consolidated. This data is not clean, there might be errors in it and stuff like this. So what you only want to do is you only want to have the data agent acting on the data which is in your gold layer, which is exactly the same data that you use for your reporting for example. So, and in this case, and this is also something which is very important here. In this case, what you want to do is that the data agent will just answer your questions the same that the questions would be answered by reporting. So what should not be the case is that the data agent, if you ask the data agent to give you the revenue from last year, it should not happen that it will give you another number than if you just look into your Power BI reporting, right? Another cool thing is because the data agent is embedded in all of this Microsoft ecosystem, the data agent knows about your identity because your Entra ID identity will be passed to the data agent as well. So in this case, you're not able to access data within your Fabric data estate, which you cannot access using other services, like, for example, T-SQL or something like this. So it's not possible that you can circumvent the security with the data agent. And everything that is configured for you will be put into place with the data agent as well. So this data agent, for example, if there is dynamic data masking in your database, right, where you only see part of the data in a certain column, then if you query this data with a data agent, this dynamic data masking will still be in place because you will just access it with your own identity. And it doesn't matter if you access the data agent or if you just access the database through some T-SQL code or something like this. Because in this case, your identity will always be looked at, and then it will be decided. Okay, well, there is this column with the credit card numbers, and Frank is not allowed to access this column, for example. Right. So the next slide is a comparison slide between MCP servers and Fabric data agents in behalf of the time, because we are really, I talked a lot, obviously. So I don't explain this slide too much, right? But the slide is in this presentation anyway. So let's think about a little bit about Azure AI Foundry, and what we can do here is, so what we will do with Azure AI Foundry is we could use Foundry models, and we could use the Foundry agent service to build our own chatbot. We can do this on different kinds of models, right? And there are also some functionality in here like Azure AI Search or Azure AI Services, Azure Machine Learning, Azure AI Content Safety. All of this can be used within the Foundry agent service. And there is also an observability layer, so you can check what the agent actually is doing. And this also is integrated with security and governance. So this could be used by different kind of tools, like, for example, Copilot Studio, Visual Studio. You could use it with GitHub. You could use it with the Foundry SDK, and you could use it from Edge with local Foundry up to the cloud with Azure and Azure Arc, for example, right? And if we're looking at the Azure AI Foundry agent service, so we see what we can build is we can build multi-agent workflows. We can what we have is we have an open and interoperable tooling, and trust and enterprise security. I already talked about this, right? So thinking about multi-agent orchestration, how does this work? So what you have is you have connected agents. In this case, there is one agent you built, right? And this agent can access the Azure AI Search, it can access Fabric, and it can also access an MCP server. And you have a multi-agent workflow, then each agent, like in this case, has a very special task. And if there is something, and there is one of these agents is like an orchestrating agent, and this orchestrating agent will pass the task to the different kind of agents who are more specialized in, for example, accessing Fabric, the data agent, or doing Azure AI Search or stuff like this. Okay, so let's have a little bit of a look at our architecture, and afterwards I will then hopefully show you a very quick demo. So architecture, how does it look like? So first of all, we have different kind of data sources. In our case, we have 3 of them. One is byte data, which is, in our case, is produced. There is a byte data stream as a demo data stream within Microsoft Fabric, and this is exactly why we choose this bike example, because we have this bike streaming data. Then we have the weather data. Weather data is a little bit, well, it's not really streamed because what we do here is we do kind of a micro batch ingestion. So what I wrote is I wrote a notebook, Python notebook, and this Python notebook will just reach out to the Open Meteo Weather API. We'll grab some information from there, and then we'll push it to the event house. Thing is that this data is also not real-time data because the least amount of time that's or the shortest time span we can use from OpenMeteo API is 15 minutes, at least in the non-paid version. And then we get the event data, and there I wrote another notebook. This notebook is getting event data from Ticketmaster, right? Because Ticketmaster is doing most of the events in London, and or at least selling most of the tickets for all of the events. So Ticketmaster knows exactly what's going on in London. And what we did here is we pushed the data from the bike data and the weather data into our event house. The event data we don't put in the event house because in this case, event data doesn't change so frequently, right? For sure, there might be some changes that, for example, a play will not happen or that a concert will not happen, but it's not like a constant flow of data, right? There will be maybe they will publish new concerts every other week. And probably sometimes a concert is cancelled, and we'll get this information as well. But this is not like that there are thousands of concerts published every second or something like this. And so we put this data in the event house. And for sure, what we do as well is we use a shortcut from the, we put this data in the lake house. Sorry, not in the event house. And what we do is we have a shortcut from the event house where our bike data and our weather data is to our lake house. So we can understand not only about bike rentals and about the weather, we can also understand about the events. What's in the lake house as well is there is also a table which just will have all the venues in it and will also have the occupancy of the venues, also how many people can be in this venue there as well, which is then used for seeing, okay, which are the big venues, which are the smaller venues, and thinking about where do we send the bikes. So thinking about this is we use the data agent to access this data. I can show you the data agent a little bit later as well. And this is everything we see here is happening within Fabric. And there are some things outside of Fabric, and this is where we use AI Foundry to build a bike dispatch agent. So the task of the bike dispatch agent is to ask the data agent for data, and then based on this data, well, this is an AI Foundry, based on this data, it will just control a bike dispatch system. And this bike dispatch system will then dispatch bikes to the different bike points. Because we don't have a bike dispatch system, what our example will do, it will just send an email, right? Because we even don't have any bikes. So this is one thing. The other thing what we can do as well is we can use the MCP server, and through the MCP server we can access the event house. As already said, there is this MCP server for Microsoft Real-Time Intelligence, which only can access the event house. And in this case, what we could do is we could use some desktop application, like for example, Cloud Desktop, to access the MCP server. All of this is modeled within Fabric like this data stream. And now I will hopefully show you a little demo of this. There I will just not share this screen anymore, but I will share another screen. So let's go here. And hopefully, can you see my screen? Okay. So if you never have seen Fabric, this is how it looks like, right? And the thing is, if you already have some experience with Power BI service, then it looks very similar, right? And so we have this different workspaces. If we go to our bike demo workspace, what we will see in here is we will see, so this is where the graph is from. So we developed it a little bit more than you've seen in the presentation. And you see that we have different kind of things in here. For example, we have our event stream bikes, which is just getting from this Microsoft streaming data source. It will get the bike events, then it will in this case, there will be a very easy transformation. We will just throw out some fields, right? And then we will write this into our KVL database. At the moment, you see, because this is not running at the moment you see that these are inactive, right? So no data is streaming in. Another thing I would like to show you is the lakehouse. So this is a lakehouse for London data. And yeah, it's always a little bit slow because I just started the fabric capacity. This is like our demo capacity here. But you see there are different kind of tables, like for example, bronze tables for bike trips or bronze tables for Ticketmaster events, and then we refine our silver tables from there. Like for example, silver table on let me see, on London venues. We have silver table where is a list of London venues. We have a silver table for the weather forecast and stuff like this. So all of this is going into our lakehouse. So well, with this said, let's just go in here as well, and let's have a look at the other things which are in here. So we have our KQL. We have our KQL database within our event house. Hopefully this will load. Okay. So you see we have our event house, streaming event house, and there we have our KQL database EH bikes, right? So thinking about agents, and this is the last thing I will show you, is we have our bike planning agent. I will just click on here, and we can ask it and hope that this will work, right? Because with the AI stuff, you never know. So hopefully I will able to ask it about our bike demo, and it loads. Can we have row-level security on data while using these agents? Exactly. Very good question. So you will have, as said with what I said when I was talking about the identity that is passed over to the agent. This is exactly what happens. And if there is row-level security for your identity, then for your Entra ID identity, then this row-level security will work as well, and you don't have to you don't have to worry about that. Through the agent, you will see other stuff that you will not see when you're accessing the data through SQL or something like this. Okay, so our bike planning agent is here. Hopefully, this is something. What we could ask it, I don't know what is happening because I'm doing live now, is what are the historical trends across all my data? This is also a very interesting thing. What you could do with AI is you can ask the AI for the unknown unknowns, because if there is something in your data you don't know about, you will not build a Power BI report for this, because in first place you don't know about this thing which is on your data. But what you can do is you can ask an AI for, okay, are there some trends in my data I might not be aware of? So I will just click here and let's see. And this might, because we don't have a very large fabric capacity here. So, but what you can see is it is analyzing the bike custo, the event house, for describing the historical patterns. It is, yeah, well, it's analyzing this, and hopefully it will come up with some answer to our question. This is the data agent. So you see there are technical issues. Awesome. So let's ask something else. What are venues? Let me see if this will work. Venues in London. Let me see if this will work. What you would not, so the other question you might have is, okay, Frank, so we have this data agent thingy here in Microsoft Fabric, but my users will not go there. Yeah, you're right. And so the thing is, what this is, so you can use it interactively like I do, right? But the real idea is to attach this data agent to some other AI capacity or to some other AI experience, like for example, Copilot for M365. If you're thinking about Copilot for M365, people might ask you following question. They might ask you, okay, look, what I can do is I can use Copilot for M365 to just query data which is in my SharePoint. It knows everything about my Word files. It knows everything about my PowerPoint files. So why cannot ask why can I not ask it just for the revenue of last year, right? Because it seems to be very intelligent and knows everything about my company. Yeah, well, I cannot ask it on my revenue from last year because this is an information which is buried somewhere in my Fabric database. And my Copilot 365 does not have access to my Fabric database. But what you could do is you could use the Fabric data agent to couple it with this Copilot in M365. And in this case, Copilot knows, okay, there is a question which can be answered through the data which is in the Fabric database. So I will pass this question to my data agent. The data agent will come up with some answer on this and then send the answer back to the Copilot in M365. And Copilot in M365 can then display your answer. So no data about venues and anonymous fund. Yeah, sometimes this this demo is a little bit quirky, I have to admit. So I will ask him. I will ask it the very last thing. What are the events in London? Hopefully, it will give me an answer on this. Sometimes, as said, sometimes all the things that I'm demoing here are things which are still in preview. So in this case, it might be a little bit. It might not be as smooth as the experience will be if this will be in production, right? At least see here there are some events. So we have. Okay, maybe these are not like events, these are more like venues. Okay. Yeah, well, so another important point. So as you might imagine, we didn't put too much effort in this demo at all because we just wanted to have some demo. So, but one thing is, and this might be the reason for this behavior here as well, is we didn't put in too much meta information about on our data, right? If you're looking at all of the different data estates you can build with Fabric, then where there are many places where you can just put some meta information like descriptions, stuff like this, right? We didn't do this, and this is something usually maybe it is not so common to put in these descriptions, although this is always a good idea to just tell the users which data is in this lakehouse or what the purpose of this workspace is, stuff like this. Putting in these descriptions becomes more crucial thinking about AIs because the AIs are also capable of just extracting data from these descriptions, extracting data from this metadata, right? And this will give them some more context on this. And probably this is what happened is we didn't tell it exactly, okay, look, the venues are here and the events are there, right? And this is the thing. Okay, coming back to my presentation, let me just switch the screen again. So we have seen a little bit of the demo, and as said, it is very complex. So if we want to dig in or to all the tidbits of this demo, we might need another 3 hours or something like this. But with this, my talk is over. So thank you very much for attending. Thank you for being here, and hope that everyone had as much fun as I had. Hope that I answered all of the questions. On the other hand, if there are any other questions, please feel free to ask.
Sir, we have one question.
Yes.
Can we have RLS on data while using these agents?
So question is, can we rely on the data while using these agents? Is it right?
Yes, sir.
Did I get the question? Yeah, well, so the thing is, yes and no. The thing is, on the one hand, you can rely on the data from this agents because this data is used to ground your agent. It's exactly the same what is happening, for example, if you ask the agent or if you ask Copilot M365, if you ask it for data which is in Word files. Because the agent, or in this case Copilot, is grounded on these Word files, it will give you answers from these files. This is one thing. But it depends on part is, well, it also depends very much. And at the moment I'm building is a very good question. I'm very happy for this question. So at the moment I'm building a little demo where I will showcase how an agent will behave if the data quality is not good enough. And this is because I think most of you are working in data for longer time, so probably most of you know already that data quality is always a big issue, right? And if the data quality is not good, then the agent cannot do so much about this, right? And yeah, well, this is a big problem. So if you want to use all of the shiny new AI stuff, one of the very big things, and this is what I think is always missing in this discussion, is that first of all, before you can do anything with AI, you just have your data, you just have to have your data quality in order, right? Because if you have only some weird data of low quality, you cannot just use this to just push it into an AI and then think that the AI on some magical thing will give you good answers, right? So my answer to this question was yes and no, because it will give you the right answers, but based on your data. And if data quality is bad, then it will just give you some bad answers. Okay, did I answer?
Yes, sir. And we have another question.
Yes. The other
How to?
question was, is that the question in the chat, or do you have another question?
Yes, sir. We have another question.
Okay.
How to
So,
build AI agent
yeah,
ourselves? Is any learning path for same?
yes. There are many learning paths on this because, as you might know, AI is a very hot topic on this. So if you go to learn.microsoft.com, Microsoft.com, I will, well, the big trick here is to do not have any typos in what you type in. So if you are, unfortunately, I have the German version now. So a very, very good starting point for this would be this here. I will shortly just put it in the browser. So there is an AI learning hub within Microsoft Learn. And you can see that all of the different kind of, so AI is not only about agents. AI is also about things like the AI services. It's about chatbots. It's machine learning. It's a very big topic, right? And what you could use is you could use this AI learning hub that I sent you in the chat to just learn your way into AI and learn the exact topic you're interested in. So you can learn on agents and maybe there is one more thing I can share with you. Give me a second. There is also a very nice course on GitHub, which is about agents. Let me see if this is. No, this was the SDK. I didn't mind the SDK. Oh, this is Microsoft Learn. Where is it? How was it called? There was like a course, and if I see it, I know it. This here. No, this is the. No, you can. Question was if the AI agent can work on a Bronx layer. So for sure, the AI agent can work on any data which is in Fabric. But the thing is, you probably don't want to use it on the Bronx layer because in the Bronx layer there is an unconsolidated data, and in this case, the agent will just give you some not so good questions. And this is something which you might do not want to have, because in this case the agent will just give, because data quality in the Bronx layer usually is not as good, because this is why you built the medallion architecture. Okay, so scenario, we have a sales report built on a high quality data set. that users actively rely on. The report uses Power BI semantic model, and we exploring whether this model can be connected to an AI agent deployed to production. The goal is to sales representative to interact with the agent. Yeah, so what you can do is you can connect the data agent to the Power BI semantic model. You would do this to the data agent. So you can think of the data agent as a gateway to the data which is in Fabric, right? So you would not use an AI agent, at least in my case, you would not use an AI agent directly. So the AI agent from AI Foundry would talk to the data agent, right? Security, the current report uses row-level security. Yes, I already answered this question. So row-level security is also maintained here, because the thing is, your identity, which you use to access this agent, will be passed down to the data agent. So the data agent knows your identity, and the data agent will also take care of the row-level security. So you will not get any data back that you're not allowed to see. How to become a good data analyst? Yeah, first of all, what you can do is you can do the certification test and listen to a podcast, right? And the other thing is, so what's a good starting point? So if you're in the Microsoft universe, what's always a good starting point is Microsoft Learn. And if you are in Microsoft Learn, bear with me for a second here, is, let me, well, this is German again. Let me learn data. Let me just check. Whoop. So what you usually will find is and maybe I will just give this link to you as well. What you usually will find is you will usually find some learning paths within Microsoft Learn, and this learning path can be adopted to your learning journey, right? So what you could do here is, for example, I'm probably sharing the wrong screen. I will just share the right screen here. So when you are in this learning path, in the training path here, so what you could do is I will click on accept here. So you can, for example, also customize your path depending on your job role, right? And to see what you would like to know. So, okay, I have to look in here. Hopefully, I will be logged in. Yes, awesome. So, and in this case, you can really customize your own learning path, which is pretty cool. The other thing is what Microsoft is supporting here as well is, meanwhile, they have like a MCP server for Microsoft Learn as well, and you can use this MCP server also from within the web interface. So you can ask an AI to build a learning path for yourself, which is tailored to what you want to achieve. Okay. So yeah, I'm sharing my screen. Anyone can see the screen with the Microsoft website?
Yeah.
Yes, sir.
Okay. Awesome. So, any more questions? The other thing is you can always reach out to me on LinkedIn, right? I might
I
not
already
answer
posted, Frank.
directly.
I already
Yeah, I saw
posted.
this. Rajendra. I saw it already. I might not answer directly because I'm always busy. But yeah, if there are any other questions, you can ask me there as well. So again, thank you very much. Have a nice Saturday evening, right? Wherever you are. Maybe the temperature, at least where you are, is a little bit better than here in Germany right now. And yeah, I had much fun to be here to present. And hopefully I will be invited by Rajendra again, right? Bye-bye.
Definitely. Thank you so much, Frank. Thank you so much.
Yeah,
Thanks
you
for
are
the
welcome.
session. Thank you.
Yeah, you are
Thank you,
welcome.
sir.
Okay.
Guys, hope
Awesome.
you like it. Thank you so much. I'm ending the session.
Yeah.
Have a good day.
Okay.
Yes,
Thank
sir.
you.
Thank you, sir.
Bye-bye. Much appreciated. Bye-bye.